Hey there, geometry. So we are moving forward in section 3.2, and I am on page 29 in our book, and we're going to continue talking about some geometric proof language and some logic pieces. Excuse me, I'm not sick. I'm sorry. I'm recording this and it's smoky out, and it's getting to me today. So we have some vocabulary we need to address. There's something called a conditional statement. And you guys are probably really familiar with those. Your parents use them with you a lot. So an if-then statement is what we call a conditional statement. So let's pretend it's a normal world and you want to go to the movies. So you talk to your parents, and your parents might say, if you do the dishes, then you can go to the movies. That's a conditional statement. You don't get to go to the movies unless you do the dishes or pay a sibling to do it. But I'm not going into that. So it's a condition. Do this, then that. So the statements, and I'm going to try to use a couple of different colors, but I've got so much stuff going on my dining room table. I'm working from home for this video. It's an evening, so you will hear background noises because when I work at home, I have a life at home. I'm thinking, let's do purple and yellow. So the if clause is what we call the hypothesis, and the then is what we call the conclusion. So I'm going to work really hard to color code this. So remember how we have been doing some algebraic proofs, and I've actually walked through this one in a video. We have if this is your equation. So this right here is what we would call our hypothesis. Then x equals 3, and that's a true statement because we did actually prove that. This is your conclusion. And so that's what this is asking us to do down here. If x plus 7 equals 10, so your hypothesis, if x plus 7 equals 10, your conclusion, then x equals 3. State the property of equality that justifies this. Well, how do you know in this example if x plus 7 equals 10, why do you know it's 3? Well, wouldn't you subtract the 7 over? So that would be that subtraction property of equality going across the equal sign. So we're going to practice some more. It's going to ask us to rewrite each of these in a conditional statement. So I'll go if you go. Well, if you go, then I'll go. And I'm going to highlight our hypothesis in yellow and our conclusion in purple. So you have to go. Then I will. This one, there is smoke only if there is fire. So if there is fire, then there is smoke. I don't know why I didn't start this one on the far left-hand side, but I didn't. It's in pen, and I'm not changing it. There we go. This one. So x equals 4 implies, this is trying to say if x equals 4, then x squared equals 16. And so over here, we kind of have a handy little box where it's talking about if P, then Q. And so hopefully that kind of makes some sense, that there's different ways that you can do this. I actually just realized I did part B wrong. Oops. It happens. And I can't redo this because this is my book and I don't have whiteout. And I'm not going to re-record this video. I did this backwards, and my apologies right here. I wish we were in class because you would have been saying, Mrs. Bishop, you did that backwards. So P only if Q. So P is the hypothesis. So if smoke, then fire. I apologize, but you know what? Mistakes happen. And we'll move on. In particular, I'm going to turn the page. Forget that problem. So let's now take a look at the next page, which is page 30. We're going to talk about something called a counterexample. So I don't know about you guys, but sometimes people don't always tell the truth. And if you just say, well, you're wrong, you're not going to get anywhere in this world. And some of you might disagree because you read a lot of that on social media, but we're better than that as people, and maybe someday we'll remember that. So we need to talk about the concept of a counterexample. A counterexample is basically when we prove something to be false. So we're going to have a true hypothesis and a false conclusion. So I want to take a look at this example right here. If two numbers are odd, and I wish we were in class because I'd be like, shout out two numbers. We're going to shout out a 3 and a 5. Well, if I add them together, I get 8. And a while back, we talked about how if you add two odd numbers, then their sum is even. Well, this isn't correct. Here's our hypothesis. If two numbers are odd, here's our conclusion, then their sum is odd. That's false. But I can't just say it and walk away or say, well, you're dumb, you don't know. No, that's not going to work. We have to have examples. So we're going to give a counterexample to show this is incorrect, but we have to start with the hypothesis. Well, here it is. If I take any two odd numbers and I add them together, I get an even. We have shown a counterexample, and we have proven this conditional statement to be false. Just so you know, being able to provide evidence of statements is going to be very important for the rest of your life, starting now. So let's take a look at some of the examples in the Check for Your Understanding. So in the Check for Your Understanding, we've got number 3. It says, if you can find an example for which both the hypothesis and the conclusion of a conditional statement are true, is the conditional statement itself necessarily true? Well, it sure kind of feels like it should be, but you have to say, in a conditional statement, if it's stated to be true, then every example has to be true. So I'm going to give you guys, let's see, an example. If I were to say, all fire trucks are red. Well, some are. So if you see one red fire truck, does that mean all fire trucks are red? No, because I've seen yellow ones out in the county. And if you live in different states, they may be different colors. So that one example doesn't prove a statement to be true. It might lead you down a certain path, but you have to state it to be true for every possible situation. And I know that wasn't an if-then, but it was just kind of a good example to use. So number 3 is no. If there's any example where it could be false, we have to go search for it. Okay, number 4, give an example of a true conditional statement that includes this hypothesis. So this is our hypothesis on number 4. There isn't enough room to write under there, so I'm going to bring number 4 over here to my margin. So our hypothesis needs to say, if an angle is named angle ABC. Well, we need to state a true conditional statement. Well, what do we know about angle ABC? Well, B is in the middle. We could say then B is the vertex, and that would be, true. Okay, because it's in the middle, that's our defined notation. Let's take a look at number 5. There might be some others, but that one to me is the one that jumps out to my math teacher brain. Number 5, give an example of a true conditional statement that includes this conclusion. So I need to have an if and I need some space. then the angles share a vertex. I'm trying to remember if we've defined this for you. But for two angles to share a vertex, like angle 1 and angle 2, then if they're going to share the vertex, they kind of have to be right next to each other. And when we define things as being next to each other in mathematics, we use the word adjacent. So if two angles are adjacent, oops, I already got the then the angles share a vertex. And that one's tricky because I can't remember if we've defined adjacent. Sometimes this book slips things in and you're like, we haven't learned that yet. So number 6, Caesar conjectures that the quotient means to divide, that the quotient of any two even numbers greater than 0 is odd. So let's take a look at number 6. So any two even numbers. So give me like a 12 and a 4. That gives us 3. What about 20 and 2? That gives us a 10. So if I divide two any even numbers, will it always be odd? No. But I can still write a conditional statement. It's just going to be a false one. So we're going to start off, if two even numbers, or let's see, let me try that again. If two numbers are even and greater than 0, then their quotient is odd. That's totally false, but I wrote it as a conditional statement. And then give a counterexample right there, that 20 divided by 2, that's an even value. Let's be done with this. I'm thinking you guys get the idea, and let's move on. Let me know how I can help, as always.